Hello guys, welcome to Mathematical Side Trips. Today we will try to answer the question, how many factors does a number have? This is our channel name, Mathematical Side Trips. And I am Napoleon A. Gaking Jr., a mathematics teacher. Okay, we know that 12 has 6 factors, namely 1, 2, 3, 4, 6, and 12. What about 1200? We will try to answer this question later. First, things to remember about factors of a number n. If x is a factor of n, so is n divided by x. For example, 3 is a factor of 12, and 12 divided by 3, which is 4, is also a factor of 12. If 2 is a factor of n, then the second largest factor of n is n over 2, or 1/2 of n. If x and y are factors of n such that their product xy is equal to n itself, we say that x and y are pair factors of n and denote this pair by the symbol x comma y. It follows that if x is a factor of n, then x and n over x are pair factors of n. Now if x and y are pair factors of n, and if kx and y over k are integers for some integer k, then kx and y over k are also pair factors of n. Similarly, if x over k and ky are integers for some integer k, then x over k and ky are also pair factors of n. So now, we'll try to answer the question raised earlier about the number of factors that 1200 have. Let us enumerate them by pair factors. Of course, the first pair is 1 and 1200. Then multiply 1 by 2 and divide 1200 by 2, we get the pair 2 and 600. Multiply 1 by 3 and divide 1200 by 3, we get the pair 3 and 400. And then we have 4 and 300. And then we have 5 and 240. And then 6 and 200. Now, if we try 1 times 7 is equal to 7. However, 1200 divided by 7 is not an integer. So there is no pair factor where one of them is 7. Because 7 is not a factor of 1200. But we have an 8 and 150 and so on and so forth. And the final pair is 30 and 40. So we have 15 pairs. Therefore, there are the number 1200 has 30 factors. Can we count without enumerating? The answer to that question is yes. But first, let us look at this definition. A prime number p that divides a number n is called a prime divisor or prime factor of n. For example, 2 and 3 are prime factors of 12, 24, 36, 72, and many other numbers. 2, 3, and 5 are prime factors of 120, 600, 1200, and many other numbers. And 3, 5, and 7 are prime factors of 105, 315, 735, and many other numbers. To count the number of factors of n, first express n as the product of the powers of its prime factors. To help us identify these prime factors, familiarity with the divisibility rules for 2, 3, 5, 7, and 11 will suffice for most practical purposes. Otherwise, try dividing n by a prospective prime divisor or by any familiar divisor like 2, 5, 25, 50, or 100. and repeat the procedure with each smaller factor until all the prime factors of n shall have been identified. Okay. Examples: 12 is 2 times 6. 2 is no longer factorable, but 6 is still factorable because it is the product of 2 and 3. And so therefore, 12 is equal to 2 squared times 3. By the way, this form of writing a number where it is expressed as the product of the powers of its prime divisors is called canonical form. 1200 is equal to 12 times 100, and 12 is 2 squared times 3, while 100 is 4 times 25. And so finally, the canonical form of 1200 is 2 to the 4th times 3 times 5 squared. And 429,975 is equal to 25 times 17,199. Clearly 25 is a factor. Now, observe that the sum of the digits of 17,199 is 27, which is divisible by 9. So therefore, this number is now 25 times 9 times 1,911. But 1,911, the sum of its digits is divisible by 3. So this number is divisible by 3. Until finally, we have the canonical form for 429,975, which is 3 cubed times 5 squared times 7 squared times 13. Next, add 1 to its exponent and multiply them. So 12 has 2 plus 1 times 1 plus 1, which is 3 times 2, or 6 factors. 1200 has 4 plus 1 times 1 plus 1 times 2 plus 1, which is 5 times 2 times 3 equals 30 factors. 429,975 has 4 times 3 times 3 times 2 equals 72 factors. Now, I have already mentioned the formula for determining the number of divisors of a number of an integer n, but in a less technical manner or mathematical manner. But this time I will have to be a little more technical about it. So, to determine the number of divisors d sub n of an integer n with prime factors p sub 1, p sub 2 up to p sub k, where p sub 1 is less than p sub 2, p sub 2 is less than p sub 3, and so on until p sub k, it is necessary to write n first as n equals the product of the powers of its prime divisors, or write n first in its canonical form. So it is p sub 1 times e raised to the power e sub 1. So the first divisor, prime divisor, raised to the power e sub 1 times the second prime divisor, p sub 2, raised to its power e sub 2, and so on and so forth until the last prime divisor, p sub k, raised to its power. Therefore, the formula for the number of divisors of the integer n is exponent 1 plus 1 times exponent number 2 plus 1, and so on until exponent k plus 1. So I have already given you the formula. I am now giving you an assignment. Find the number of factors of the following numbers: 504, 1,782, 29,250, 253,575, and 72 cubed. The answers are given in the same slide, so try or enjoy finding the number of divisors. That is all for now. Thank you for visiting this channel. and God bless.